Hello friends, welcome to my YouTube channel. My name is Prathmesh. Without wasting our time, let's begin. And if you like, please like, share and subscribe.
An automated assembly line produces hundreds of units. Instantly, the conveyors stop, robotic arms freeze, and the entire facility goes pitch black. 2024 data reveals an 87% surge in ransomware attacks against industrial infrastructure. Manufacturing absorbs over half of these incidents, remaining the primary target. Geographically, these hits concentrate heavily across the US, Canada, and Germany. The impact of these breaches is highly tangible. In 75% of these incidents, the targeted organization suffers a noticeable physical disruption to their daily operations. But the high-impact scenarios are increasingly common. 1 in 4 attacks forces a full site operational shutdown, knocking entire supply chains completely offline. This raises an immediate question. Why are isolated industrial machines, systems that never browse the web or open emails, suddenly vulnerable to standard ransomware operators? The common assumption is that attackers deploy specialized exploits custom-built to compromise industrial logic controllers. The data proves otherwise. This surge is driven by standard corporate IT breaches. Threat actors gain access to a standard office network and then bleed over into the operational technology environment because the underlying network architecture is left undefended. Internal architectural flaws now represent the primary risk, allowing a single stolen corporate password to trigger a factory floor crisis. Look at this topology diagram mapping a flat network architecture. On one side, the corporate IT environment, laptops, email servers, and VPN gateways. On the other side, the operational technology, housing the hardware controllers and machinery interfaces. Notice the direct, unblocked pathway connecting these two distinct zones. Approximately 75% of all cyber attacks on industrial control systems originate right here, in the corporate IT network. Attackers typically gain access to the IT side through familiar mechanisms, compromising a VPN gateway or deploying stolen corporate credentials purchased on the dark web. They target IT first because it offers a standard, well-documented environment. It provides a reliable foothold using conventional cybercriminal tactics before they attempt to pivot deeper into the infrastructure. Once inside, the flat architecture enables lateral movement. The threat vector slides directly across the network bridge, completely unobstructed, and enters the OT environment. In 2024, the number of ransomware groups targeting these systems rose by 60%, as attackers who previously ignored industrial hardware recognized the vulnerability of these flat networks. Upon arriving in the OT environment, the attacker encounters a system heavily reliant on older legacy technology. These legacy systems were designed for maximum uptime and closed-loop efficiency, meaning they lack the internal software defenses necessary to stop an intruder who has already bypassed the external IT firewall. Ransomware groups now recognize this flat architecture for what it is, an easy, high-leverage target for extortion. Until this network topology is redesigned, an organization's multi-million-dollar industrial machinery remains only as secure as its weakest corporate employees' login credentials. The primary architectural solution to lateral movement is strict network segmentation. Returning to our topology map, the direct pathway connecting the IT and OT environments is now structurally severed. The core principle here is total internal isolation. By disconnecting the operational technology network from the corporate IT environment, you eliminate the free-flowing bridge that attackers rely on. In place of the open bridge, architects insert a DMZ, a demilitarized zone. This space is populated with internal firewalls that act as a mandatory structural checkpoint between the two separated networks. These segmented zones function exactly like watertight bulkheads on a ship. If one section floods, the bulkhead seals, containing the effects of an attack to a single isolated area. In a simulated attack on a segmented network, a corporate VPN is successfully compromised. But as the attacker attempts to move laterally toward the machinery, they strike the DMZ firewall layer and are permanently halted. Segmentation forces the attacker to overcome specialized secondary internal barriers, which neutralizes the advantage they find in flat networks. This structural defense directly addresses the 25% physical shutdown statistic. By trapping the breach within the IT environment, the operational hardware is never exposed. Architectural segmentation reduces a systemic failure into a localized IT incident that allows production to continue uninterrupted. While segmentation contains the spread, securing operational continuity requires a secondary failsafe, rigorous offline backup testing. For a backup to be truly offline, it must be physically or logically severed from the active infrastructure. Notice this backup server is entirely disconnected from the main network grid, existing completely isolated in its own space. This isolation is critical. Modern ransomware algorithms are coded to seek out connected network backups, traverse the network, and encrypt the recovery data before locking the primary systems. Because the offline backup cannot be reached via lateral network movement, the attacker cannot destroy the organization's recovery data. Organizations that implement and routinely test these offline systems demonstrate significantly shorter recovery times following an active incident. Restoring data independently means the organization never requires the attacker's decryption key. Without the key, the attacker holds zero leverage for extortion. Network segmentation halts the initial spread of the ransomware, while offline backups guarantee that even if a breach occurs, the organization can maintain its physical output and refuse to pay the ransom. Industrial infrastructure is now a standard target for cybercriminal groups. Adversaries who once ignored industrial systems are now aggressively exploiting them for high-impact disruption. Legacy operational technology systems are no longer obscure. They are highly visible targets for extortionists seeking the leverage provided by a physical site shutdown. Compare these two architectures side by side. Traditional corporate perimeter defenses are no longer sufficient to keep threat actors entirely out of the industrial environment. The data lays out two distinct futures: the severe operational vulnerability of a flat network, or the localized, survivable containment of a segmented network. Lasting resilience is built through structural architecture, focusing on internal containment rather than internet edge defenses. To secure operational continuity against this surge in ransomware, network architects and operations managers must immediately prioritize internal segmentation and verified offline backups. As IT and operational environments converge, protecting the physical machinery of the world requires engineers to structurally rebuild the digital pathways that control it. A modern manufacturing plant operates with precise mechanical momentum, but when the digital commands controlling that machinery are suddenly encrypted and locked, thousands of pounds of heavy industrial equipment violently grind to a halt. This physical seizure stems from a massive escalation in cyber warfare. The 2024 data marks the transition of industrial sabotage from a theoretical risk into a measurable operational reality. This chart tracks cyber attacks targeting industrial control infrastructure. During 2024, data shows a steep 87% year-over-year surge in total incidents. This spike is driven by a 60% increase in ransomware cartels engineering operations specifically to target operational technology and industrial control systems. For years, financially motivated adversaries ignored complex industrial systems because they required specialized knowledge to breach. Now, those same groups see physical hardware as a highly lucrative extortion target. This threat is highly concentrated. The largest volume of successful attacks consistently land in the United States, Canada, and Germany. These three specific nations carry the highest risk because they possess massive, established industrial bases that rely heavily on aging digital infrastructure to maintain production. Ransomware cartels have adopted industrial disruption as a high-volume extortion tactic, scaling a capability that was once limited to specialized state actors. An anomaly emerges when we examine the 2024 data closely. The catastrophic impact of these attacks is not distributed evenly across all industrial sectors. This breakdown shows the distribution of targeted industries. Manufacturing accounts for over 50% of all observed ransomware victims within the industrial space. This is a persistent structural issue. Manufacturing has remained the absolute most targeted industrial sector for 4 consecutive years. Heavily regulated sectors, like energy grids or regional water utilities, experience significantly lower volumes of successful extortion, despite utilizing similar heavy machinery. Why is the manufacturing sector uniquely vulnerable to these specific cartels compared to other heavy industries? Answering that requires moving past basic attack statistics. We have to analyze the underlying network topologies to see exactly how attackers bridge the gap between corporate IT offices and physical operational hardware. To understand the mechanical realities of an industrial breach today, we have to start at the digital perimeter. There is a common assumption that attacks on industrial systems begin with a sophisticated, direct assault on operational hardware itself. The data proves otherwise. This topology model shows that approximately 75% of attacks on industrial environments originate with a routine breach in the corporate IT network. The most common initial entry points are unpatched corporate VPNs or compromised employee credentials. Adversaries log in through normal corporate channels. At this early stage, the attacker is not looking to break machinery. Their goal is simply to establish a quiet, persistent foothold within the corporate environment. The critical phase occurs next. IT to OT convergence is the precise moment when a standard corporate data breach escalates into an industrial crisis. The true systemic vulnerability lies in the internal architecture that dictates what an attacker can access after they secure that initial IT compromise. To understand why manufacturing fails where regulated industries succeed, we have to compare their internal network architectures side by side.
The left side models a regulated sector with strict Purdue model segmentation, distinct IT, DMZ, and OT layers. Heavy firewalls block intruders. The right side shows the manufacturing baseline, a flatter, converged network where corporate IT interfaces directly with factory OT systems. Unlike the strict utility model, modern manufacturing facilities have historically relied on this flat architecture. There is a specific operational logic here. Manufacturing prioritizes maximum efficiency, rapid production logging, and seamless communication between business logistics and factory output. However, this operational drive for constant, frictionless data availability effectively dissolves the internal security boundaries that would normally trap an intruder. The business requirement for hyper-efficiency in manufacturing inadvertently creates the exact structural pathway ransomware groups exploit to reach the factory floor. Once the internal architecture allows for it, we can track the attacker's progression from their corporate IT foothold straight toward the physical operational hardware. In lateral movement, attackers quietly navigate the flat manufacturing architecture. The network treats them as authorized traffic, triggering no alarms. Crossing into the OT environment, they frequently encounter outdated, unpatched legacy programmable logic controllers, or PLCs. These legacy industrial systems were originally built for reliability and decades of continuous longevity. They were never designed to face modern, internet-connected threats. Ransomware groups deliberately scan for these specific legacy vulnerabilities. They know that factory managers cannot easily take these older systems offline for security patching without halting production. The combination of lateral movement through a flat network and the exploitation of legacy vulnerabilities turns a routine corporate credential theft into a direct, weaponized threat against physical hardware. Network theory eventually yields to devastating real-world operational consequences. Once compromised by ransomware, approximately 75% of incidents cause significant operational disruption to the facility. The most severe 2024 metric shows exactly 1/4 of these incidents result in a catastrophic full shutdown of a site. Manufacturing operates on razor-thin margins. Every single minute of machinery downtime incurs massive compounding financial losses that threaten the survival of the business. Ransomware cartels are highly successful in this sector because they weaponize the industry's low tolerance for downtime. They lock physical machines, knowing the resulting financial bleed will force a rapid ransom payout. Mitigating this risk requires organizations to implement strategic solutions to stop lateral movement entirely. Perimeter defense alone is insufficient. Modern industrial security must operate on the assumption that the corporate IT network will eventually be compromised. The primary mitigation is strict internal network segmentation. Facilities must sever IT to OT pathways to contain corporate breaches. The secondary requirement is fully offline backup systems. If held for ransom, the facility can wipe the system and restore from an isolated copy. Organizations deploying these two specific controls significantly shorten their recovery times during the chaos of an active breach. By physically isolating lateral pathways and securing offline recovery, manufacturing organizations strip attackers of their operational leverage, significantly reducing the likelihood of ever paying a ransom.